Alright, so let's go through this Trails of 13 which I adapt from Xinmin Secondary Sec 3 end of year 2022. So a student drops a ball from a height, right? So the ball hits the ground and rebound. So we are given the velocity time graph at 1.2 seconds. The student catches the ball. So this is the end of a journey. So okay, part A, state the number of times the ball touches the ground. Okay, so if you look at this velocity time graph, the very first part is where the ball dropped. So of course at 0.4 second the ball hit the ground at roughly 4 meter per second. So of course the speed will drastically decline until 0 meter per second, right? So this is where you are still in touch with the ground. But in order to rise, you need to gain speed in the opposite direction. So at this part, at the negative region, you're actually gaining speed, but still in touch with the ground. So for this, you're actually gaining speed in the opposite direction. Then at this particular part, you begin to rise already. So you rise, you will slowly reach the maximum point. So you will rise, right? So this is rise. Then after that, at this point is a maximum point. Then after that, you drop again. So you drop, then same thing, you drop, you hit the ground at roughly 3.4 meter per second. Then after that, right, you hit the ground again. So you decline in speed until 0, then you gain speed in the opposite direction. Alright, okay, so state the number of times, very simple. You just look at how many vertical lines you see. So you just look at, there are 2 vertical lines, so there is 2, the ball actually touched the ground 2 times. So the green region is actually when the ball touched the ground, right? Okay, for part B, determine the acceleration at 0.25 is around here, 0.25. So since it's a straight line, right, you just simply calculate. So it is okay. So for example, I take this and this. So rise over run. So rise is 2, run is roughly 0.2 seconds. So rise over run, you just use acceleration equal to rise over run. So rise is 2, run is 0.2, right? So 2 divided by 0.2, roughly 10. Okay, so it's 10 meter per second squared. So this is what we call the acceleration of free fall. Okay, part C, determine the height at which the ball is dropped. Okay, so when you want to determine the so-called the initial height, you must always look at the very first part of the graph. So means that, okay, if you look at this, right, there are many parts, many triangles. So you just need to look at this first part. So the first triangle. So the first triangle, you just need to calculate the area to determine the distance. So half time base times height. So it's roughly 0.8 meter. So the initial height is 0.8 meter, right? So this is 0.8 meter. Okay, so part D will be a qualitative question already. So explain how. Especially when they ask us to use the graph, we must always refer back to the graph. So explain how the graph shows that the height reached by the ball after rebounding, right, gets shorter. So this one is just referring to the area. So for example, right, if you look at the very first part is 0.8 meter. So the second triangle, this is where I rise to the maximum point. So when you rise to the maximum point, you realize that the area is smaller. Okay, so this is how we explain. So you just need to say from 0.4 to 0.7 second, the area under the graph is smaller. Okay, yeah, so that's how you explain. Okay, so part E will be the last part of the question. So plot the speed time graph for the entire journey. So for the speed time graph, right, every time you see a speed time graph, you can just ignore the negative region already. Alright, so you just focus your attention on the positive region of the graph. Okay, so same thing. I drop the ball. So at the start is 0 meter per second. So before I hit the ground at roughly, okay, let me go here, 0.4 second, right? So I will reach a speed of 4 meter per second, right? So okay, just need to draw a straight line using a ruler. Okay, next will be I hit the ground at 0.4 seconds. So my speed will decrease drastically to 0. But I will, before I rise, right, I will have a so-called speed of negative 3.6 meter per second. So 3.4 meter per second. Okay, so at this rising part, you just need to sketch at the same part of the graph. So you just draw here. So 3.4 is roughly here. This is where you begin to rise. So you rise, right? You will 0.7. Okay, so rise, you will go to 0.7, which is 2, 4, 6, 8, 10 here. So you just use a ruler to draw. So this part is where you rebound for the first time. Okay. After that, you continue on. So from 0.7 second, okay, from 0.7 second to 1 second, right, you will drop. Okay, so 1 second, so 1 second. So you will reach a so-called speed of 3.4 again. So 3.4. So this will go here. Then last but not least, so at 1 second you hit the ground. Okay, hit the ground again. So hit the ground, then just decrease. After that, okay, before you rise, you have a speed of roughly negative 2.4 like that. So negative 2.4, we just put in positive region. So negative 2.4 or 2.4, 2.4 is right here. So this part is where you begin to rise. You must always draw at the same vertical part. So you rise, right? So you just draw until 1.2. So that is how you sketch the speed time graph for this bouncing ball.